And now for a quick lesson on arc length. Quick review on what it means to be a circumference. The circumference of a circle is the distance all the way around the circle, and that formula is completed with 2 pi r. However, arc length is related to circumference, but sometimes you don't want to go all the way around the circle. Sometimes you just want to go a portion of the way. So when that happens, we change the word from circumference to arc length, and we change the formula just a little bit. You can see that it still has the circumference formula, but instead of going all the way around, we only want to go a fraction of the way around, and that's what this represents. So instead of going all the way around, we want to go a fraction of the way around. So this is the formula that we will be using today. So we have 2 examples to work with. Example number 1, we're going to find the length of the highlighted arc. Arc length, which I'll abbreviate as AL, we're going to use this formula. This is a theta, T-H-E-T-A, theta, and it represents an angle measure. So if you look in the picture, you can see that this angle is represented by 120 degrees. So 120 degrees over, the 360 will always be there, that never changes, times 2 pi, and recall that the radius is the distance from the center to the edge, so the radius will be 6. At this point, I get my calculator out. As long as you are handy with a calculator, this is not a bad calculation. We'll make a fraction, 120 over 360 times 2 pi, and the radius was 6, and that's my answer. You can round however your teacher tells you to round. I typically round to the nearest thousandth, so I write down the first 2 digits, and then the third digit rounds. That will remain a 6. And arc length, because it is a measure of circumference, the units are just plain. So this would be centimeters. So again, angle measure goes here, radius goes here, calculate it out, and leave the answer how your teacher wants it. For a more complicated question, if the arc length of AC is 5.236 centimeters, and the angle measure is 20 degrees, what is the radius length? So this one's asking you to solve backwards. I've drawn a quick picture of what that looks like. So we have a circle with an arc length AC. The distance from A to C is 5.236. The angle measure is 25. I do not know what the radius is. I'm going to attempt to fill in the formula the best I can. I have the angle measure of 25. I do not have the radius, so the rate r is going to have to remain. So the question becomes, where do I put the 5.236? Well, that's going to go in for the AL. That's going to go in for the arc length. So it is possible to plug numbers into the other side of the equals. This takes a little bit of skill and a little bit of calculator practice. In order to calculate this, the first thing I'm going to do is in my calculator, I'm going to put 25 over 360 times 2 times pi. And I'm going to make sure that you can see that. So in my calculator, I am putting 25 over 360 times 2 pi. You will notice that I did not put the r in. I'm just putting in the numbers, and I'm going to write this down. So 0.43633. And then the r is going to carry down. Most students, once they get past that step, they have no problem finishing. To continue getting r by itself, we will divide by that ugly fraction, ugly decimal I should say. Again, I will go back to my calculator. 5.236 divided by 0.43633. And I am going to round that to 12. That was my intention when I wrote the problem, so we're going to write that as 12. So my radius will be 12. And a radius is a length, so it would be in centimeters in this case.